Hello and welcome to PodRocket, a web development podcast brought to you by LogRocket. I'm Noel, and today I'm joined by David Mytton, founder and CEO of Arcjet, here to talk about the recent React security stuff, everything that's kind of going on in the web JavaScript world. How's it going, David?
Hey, I'm good. Thanks for having me.
Of course. Yeah, this will be an interesting one. I feel like everyone kind of is at least peripherally aware of this, but like depending on where you are in the stack, or maybe how many legacy apps you're maintaining and what kind of traffic they get, there's just like this kind of been this flood of stuff going on. I think the big one is the Reactor Shell thing. That's probably like the main cornerstone people are talking about right now. You want to kind of start there, and we can explore from that direction.
Sure. Well, we're talking on December 15th, and the Reactor Shell vulnerability was announced on December 3rd. So we're probably at the point where most people have patched, I would hope.
Hopefully.
I hope people have patched. But it's been a fun 15 days almost, not even 15 days. December with security in JavaScript and React has been challenging, and this is just flowed in from the supply chain issues that we've had with the Shai Hulud attacks. The first one earlier this year, and then it happened again just a few weeks ago. So the React to Shell vulnerability is really the biggest one that has caused a lot of people to scramble, just because it is a classic worst case scenario where the latest version of React 19, and anything that depends on it has a flaw that allows anyone to execute code in your environment, which allows you to extract environment variables, allows you to install things and run crypto miners. We've seen that. It's kind of a classic. You get a vulnerability and someone's going to mine crypto as a result of it. And then the more nefarious ones are being able to exfiltrate data, make requests in internal infrastructure. And this is not just React 19, which is the latest version of React, and probably only new applications are really using that. The other ones are probably still on the older versions because it's quite a big lift to do the upgrade. But the real challenge has been that some of the popular web frameworks, particularly Next.js, depend on React 19, even if you're not actually using it. And that goes quite far back. They've released patches for Next 13 and 14, but certainly it was announced in React 15, in Next.js 15, that React 19 was bundled as part of it, even if it wasn't enabled. And the release of those Next packages was interesting because it doesn't necessarily show up in your dependencies, because Vercel bundled it as part of their experimental work to gradually introduce it. And so this means that the Reactor Shell vulnerability has a pretty big surface area for the potential for exploitation.
So let's talk kind of the specifics of that surface area here a little bit. Like what kinds of apps are vulnerable? Like is this any app, front-end only stuff, or is there a concern there?
So it's any application that supports React server components, even if you're not using them directly. So typically these are exposed through server functions, which is a new way to execute server-side code. Typically as like a form handler dealing with some kind of action in your code. It was a way to just make the developer experience a lot more smooth, a lot smoother. But this necessarily meant that server-side code was being executed, and it was essentially just another API endpoint. It just didn't feel like one to developers. You could put SQL in there. It was easy to make mistakes around putting in secure access that was then exposed on the server. And this meant that it has a wide surface area that might be surprising in many ways. And so the way that this was vulnerable was through the type of payload that got sent. It's how React decodes payloads that get sent to those server function endpoints. That meant that an attacker could just send a certainly crafted payload into your application, which could include commands that could then be executed on the server.
Earlier this year, there was a lot of supply chain stuff going on. Like this, there was like npm was the vector a lot of the time. So you'd install some bad package, it would have the vulnerability. This feels a little bit different to me, like in that this feels more like I don't know, like the SQL injection attacks of old, or like you're running a bad version of some like Nginx server thing or something like that, where there's like a piece of infrastructure that has some exposed, surface area. Do you think that that's a fair mental kind of classification? Should we be thinking about these things separately anymore, or is that not a meaningful distinction any longer?
No, it's definitely meaningful, and I think it's the right way to think about security. You've got this line of pre-production and production, and anything pre-production is as you're writing codes in the development environment, and the risk is the individual developer's laptop and what they might have access to on that laptop. Mm-hmm. So you might have credentials in environment variables or in a file in your home directory. Could be a session to your AWS CLI, for instance, and it could be access to database through remote access. It's anything that the developer's environment could touch, including your source code and the ability to ship things into production. The line where the Reactor Shell vulnerability came in is once that code is in production, because it's sitting on the internet, it's available publicly. You can send in arbitrary requests because that's what it's designed to do. It's going to serve user requests. Mm-hmm. And where you have this remote code execution vulnerability means that the attacker could send in a command. The way that it's passed meant that it would then be executed on the server. And so anything that the execution environment has access to could be used. Now, typically that's things like database access, the ability to run code, to install something, to do something on that server with the CPU. And that is particularly challenging because it's your production environment. You've got real data, real users, and the ability to do things that are perhaps a little bit different than what's on the developer laptop.
I think that there's been a lot of noise made about Vercel and them, especially if you're running either with them or one of the other big hosting providers, right? And like they're running all these services for you. Have there been updates from them to just like update deployed apps to patch this like in real time without needing like action on the developer's part?
Yeah, the different providers have done different things. So someone like Vercel, they're closely working with Meta, who are the developers of React, and Vercel is responsible for Next.js. And these are the two big service areas. So they've taken the majority of the responsibility, but they participated in a program where they collaborate with other vendors, even competitors. Yeah. Because it's in their interest to maintain the security of the ecosystem. So the way that Vercel and other providers reacted is the disclosure was made internally and privately, and then a group was spun up to discuss the vulnerability and the mitigation for it. And then there was coordination between the likes of Vercel, Netlify, AWS, Google, Fastly to deploy multiple levels of mitigation. The first is web application firewall, and this runs on the network. It examines all your traffic before it hits your environment, and you can use that to create rules to detect whether someone is making an attack and either block it or mitigate it. And you can do this by looking at, there were certain headers that could identify the attack. But there were even cases where those headers weren't present and a certain payload was sent. But you can inspect the payload, you can discover the particular signature of this attack, and then you can block it. So that was kind of the first layer. We also saw some of these vendors implement runtime mitigation. So even without the firewall, they were able to make changes to how the JavaScript runtime executes in their environment to remove the area of vulnerability. And so this meant that in some cases, we were seeing security scanners going out, finding supposedly vulnerable versions of these applications, but actually there was no route to actually executing the vulnerability because they'd implemented these runtime mitigations. Good. And that happened even before the announcement of the vulnerability. Mm-hmm. And the goal there is industry participation, make sure as many production applications as we can find have these mitigations in place to buy security teams enough time to do the patch. Because as soon as that vulnerability came out, we started seeing people trying to bypass the web application firewall. Right. And the Vercel CTO actually tweeted over the weekend, they set up a bug bounty program, and they paid out at least 15 different WAF mitigations for that vulnerability over 48 hours. So you can see there's this kind of tug of war happening. And so there's a WAF mitigation put in place, and then researchers are trying to find their way around it. And then they patch that, and then there's another one and another one.
Mm-hmm.
And the goal with the WAF is to give you enough time so you can patch your application, because that's the ultimate way of securing things. And it's easier said than done in different applications. Like you might have to bump multiple versions. This is part of the challenge with the JavaScript ecosystem in general, I think, is there's a lot of version churn. There are new versions all the time. And different projects treat their versioning differently. Some might be very semantic versioning. Some things won't break. Other versions might have just a minor patch release and it breaks your application. So patching is the best way to resolve this, but it's also not necessarily the easiest way to get the fix into production, because you could break your application.
Especially when it's it's React. It's like probably it's probably like your kind of main dependency, right, for like most of these applications. So that, and then that paired with other dependencies that may, like, you get into the typical these giant dependency trees that JavaScript apps tend to have, where it's like, oh, I want to upgrade my React version, but this thing's broke, so there's all this, like, there's all these races.
This is the real issue.
Exactly.
It's the real expanding dependency tree. Like even just installing one or two dependencies in your application, your dependency tree could explode because of the tendency within JavaScript to reach for a package rather than re-implementing sometimes trivial functionality. The whole point of a library is to stop you reinventing the wheel, and that makes sense in a lot of cases. But we've seen in JavaScript just the explosion of these dependencies, which makes it really difficult when there's a security vulnerability to either update one you've deliberately installed, or maybe it's like 3 levels down in the dependency tree.
I want to kind of get into the nature of JavaScript a little bit in these recent attacks. But before we do that, I want to talk a little bit more about the kind of response, the like industry insiders and the outsiders, and just this kind of whole relationship with the centralization. There is a version of this, or maybe an argument that could be made, that this kind of mode where that we can get a handful of players in the room and be like, okay, we're going to try to mitigate this on the inside, get this WAF set up so we can like control it for most people. If you're using these tools, but you're outside of the core ecosystem, you are like at an inherent disadvantage there, because you're like, I'm not being given information, but I might have this vulnerability, but I'm like left on the outside. Is this a problem at all? Like, do you foresee this as like something that like there could be improved process here, or is this kind of the best we can do with the level of centralization that we have with the Next ecosystem currently?
The way it worked for Reactor Shell, I think, was near the best you can get, because you had proper vulnerability disclosure, there was an investigation, there was a fix, and then the platforms where most of the applications are deployed all collaborated to get a mitigation in place to buy time. And then Vercel went a bit further with the tooling they released. They blocked deploys of vulnerable versions very quickly. They also released a set of tools to do automated patching for you from a CLI. And then later they released an AI agent that can do the patching for you. And if you just got one or two applications, then patching is a manual process. It might be a bit of a pain, but you could go through it and do it. But there are organizations that have thousands, tens of thousands of applications deployed, and doing that upgrade is a real pain. Imagine coming in on the weekend and then finding a Dependabot PR for 10,000 applications to update. And do they all have tests? Like, testing the UI is one of the hardest problems ever. So this becomes a real challenge. The process has improved, though. If you look back at historic vulnerabilities, certainly in Next.js, but in JavaScript in general, the Next.js security disclosure process has improved. They get volunteers involved from, or they get the platform vendors to volunteer to join this group. You can be brought in if you're a platform vendor, and they're pretty good at the communication side of things. But there is no real central place to go as a developer to find where all these vulnerabilities are announced. And there really hasn't been in any project. I can only think back to the mailing lists for Linux distributions, where you might get the security emails sent out. Like Node itself has that. Go has it for security now, so they have a process. But for the individual packages that you might be relying on, some of them are going to be open source. You got to follow the GitHub releases. There's no announcement mailing lists. Finding out when the CVE number is attached to a vulnerability, that process is centralized. There are CVs minted all the time, just keeping up to date with all those. And then the fact that there's a security vulnerability doesn't necessarily mean you're vulnerable to it, or maybe it's not a high priority one.
Right. I think that's that's a problem, right?
How do you start triaging it?
Mm-hmm.
So this is a real challenge, and there are tools that try to solve it, but I don't think there's really anything that's done an amazing job at achieving that for developers, for security teams, and it's just a lot of alerts that you've got to triage.
Yeah, I mean, I get it all the time. Like I have just even like a lot of GitHub repos, right? That like there's not even like an actively deployed version, but they're these open ones, and like I bet I get 3 or 4 emails a day on like some packaging bumps. I'm like, this thing hasn't been deployed forever, and I'm not going to go do it. But I think I do lose signal in the noise that I'm just getting all these alerts all the time on security vulnerabilities, and like I don't know. I'm an open source maintainer. Like I'm not. I don't have time to go patch stuff on these old projects nobody's even looking at anymore. And I'm sure I could do some work and clean things up and archive stuff, and it would be better. But like,
it's a lot of noise. GitHub's become a lot better at doing it, and having that security tab in the repository and giving you like a daily summary of vulnerabilities. But if you have more than a few projects, that clips, and then you can't see them all, and it still becomes a challenge. Like we use a tool called Socket that helps us when we're doing dependency updates to analyze them. We're part of mailing lists. We're in the Next.js and that React group for platforms that deal with security, because Arcjet is a security tool, so we're part of that. We keep an eye on the dependencies that are most important to us. But there are some philosophies as well. Like we try for our SDK, for our security SDK, we currently have, I think, 2 third-party dependencies, and we're working on removing them. And we have a very high bar for adding new ones, and we haven't added a new third-party dependency for 2 years now. And our goal is to depend on, for our core product, when a customer installs it, we want them to only have to trust us and nobody else with our code. And like, there are things like you don't want to re-implement a database driver in most cases. There are things that you're going to bring into your code base that do things that you really need, and it's not your core business. You shouldn't be re-implementing them.
And they're probably going to do them in a more secure way than you were if you were to write them yourself. So it's a little bit of like a double-edged sword. It's like, do I trust these? Like, I'd rather use something that I know someone's focusing a lot on because they're going to do it right. But again, you have another dependency.
Exactly. And we're being really strict about what you bring into your application, and then understanding how their security is. Is it just a single open source maintainer? That's one thing, versus an entire company behind it. And there's a spectrum between them. And it's not that you can't trust one and trust the other. It's just understanding what your risk profile is there. But it's just difficult. That's the problem.
I think it is difficult, but I do think the magnitude of these that we've seen over the last 6 months, any JavaScript developer with their ear to the ground a little bit is feeling this. Like I think this is in everyone's mind a little bit more. And we had you mentioned Socket. We had Pharos on several months ago. And like we were having a very similar discussion of just like, I think that this is a thing that's in everyone's mind. So I guess let's kind of explore that a little more. Is there something unique to the JavaScript ecosystem? I mean, I think that there has always been a mantra of just like pulling things, don't think about it. But is there something else beyond just kind of that being the ethos that is leading to this problem here specifically? Is it just the magnitude, the size of it, or is there something fundamental with how our apps are being built where we're having more of these problems again now?
I think there's a cultural component, which is just user dependency for everything. So there's that. And then there's this idea that you should rely on the dependencies from other people and just assuming that's the case. I think that's a very old school internet approach. A lot of people in the early JavaScript community came from that era where you could just trust most people on the internet, certainly in engineering circles. You could bring in things, you'd assume they were high quality and they were maintained by people. But one of my engineers made this point to me just a week ago, that quite a few people have churned out of the JavaScript ecosystem, particularly the more senior people. And as we see more and more people come in, because JavaScript is so accessible and it's so easy to work with, and AI has such a huge corpus of training data that people can come in and build amazing things on the surface, but perhaps the quality isn't quite as high just because they're so new to the industry. And this causes a problem because people don't understand, or the code quality just isn't there. And the people who might have spent a lot more time on these things have moved to other ecosystems.
Yeah.
Because JavaScript wasn't supposed to be a server-side language, and now it's being used for everything. The constraints and the controls that you might have on like a more strongly typed language or something that has more secure defaults just aren't there, or you have to do extra work to get access to them. Like people still use JavaScript versus TypeScript, and that's an interesting question. So why would you use raw JavaScript today when you've got all the controls of TypeScript? And there are reasons to do that, but you have to know what they are.
Right.
Yeah.
The reasoning that, like, this has just been the culture and the ethos, and that's why we've had these like supply chain attacks. I think that that makes more sense in my head. But I don't know if that really kind of helps smooth this at all for the React Shell thing. Like that feels like a different kind of problem. Like, because in my head, that's not like I had too many dependencies. It's like I'm going to use React. Like, right, even if I'm being very stringent, right? It's like I could still expose myself to this one. You mentioned this kind of pushing JS into the server. I think that there's a whole smattering of debates which could be had on, like, is the RSC membrane like clean enough and easy enough to understand? Is there a user component that's really at fault here for this one, or is this mainly just the like the one of those that's like hard? It's hard to blame anyone other than the React team as much as we could blame someone.
Yeah, I agree. I think even something like Java, the log4j vulnerability is very similar to this.
Right. Yeah, that's a good example.
And Java is a very mature language, and there's lots of developers for it, and it's server side, and we still had that very fundamental vulnerability, which caused a lot of people to scramble. And this is a similar class it's the same class of vulnerability, and it's the same kind of exploitation. Right. And it's not because the culture needs changing or anything like that. It's just because JavaScript is popular and people want to do lots of things with it. And there are going to be vulnerabilities. There's no 100% secure anything. Right. Mm-hmm. And I think it's just going to be the nature of it. And in this case, you just have to be paying attention. You have to know what your platform provides you from security with mitigations. You need to have a way to update and keep on top of things. And it's just keeping things running smoothly, best practices, as opposed to the other ones like Shai Hulud, is because the defaults on NPM was to run scripts as part of the install process, which is probably not a good idea. And it's just the defaults there have caused problems for people. Whereas with the Reactor Shell, it's not really the defaults as such. It's just that a mistake was made.
I used the word blame before. I don't know if that's like totally a fair. There's going to be vulnerabilities in everything we do. It's a lot probably aren't discovered, and then like the super heavily trafficked ones are going to get picked up. And like I think that is probably going to be part of it. I think these ones are always particularly tough because it's like, as a user, it's like you want to do something different. I don't know if there's like a huge takeaway from me on this one other than like be ready, like be ready to update stuff. Maybe this is another one in that, like, always be on as late a version as you can be, so when you need to patch again, it's easier to do that, and you're not like trying to struggle through.
But not too up to date, because there might be malware.
Exactly.
In the latest version.
Yeah, that's true. Some of these other ones more recently, like you wouldn't have had them if you hadn't updated. So that's an interesting question. While we're here, how do you square that circle? What do you tell developers when they're trying to figure out how near the cutting edge they want to be on versions?
This is the big challenge, and you can't stay too up to date because you might accidentally bring in a vulnerable package because someone got compromised and released malware into the latest version. So I think the difference there is automated updates versus manually patching something because there's an ongoing vulnerability. And the real challenge with staying up to the latest version, even just not pinning your dependencies in the correct way with the correct characters in there so that it always updates when you run an npm install. You should be doing just little things like use npm CI rather than npm installed, so you can use your package lock. And don't bring in point versions of dependencies in an automated fashion. Like don't reinstall the latest version in CI or on your development machine. Make sure they're all pinned, and that can avoid a lot of these the package compromise vulnerabilities. And then the setup to your development environment. Like we use dev containers at Arcjet so that even if we do accidentally bring in a compromised package into our development environment, it's contained within the container.
Yeah,
and it's not actually on the host laptop, so it doesn't have access to anything else. So for those kind of things, it's more about your overall development practices and just slowly updating. But you've got to be on the latest version, the latest major version, as soon as you can, because although in this case, Vercel did release patches going all the way back to Next 13, their official support policy is that they only support the latest and the previous versions. And so you're reliant on the vendor to be able to do that backporting, or you're going to have to do it yourself if you're on really old versions of things. And it's just bringing in more and more maintenance overhead, because you might have 1,000 applications and you're going to keep them all up to date when maybe they're just doing the job that they need to do and they don't need to be changed.
And I feel that there's kind of an arithmetic that one is always playing when you're looking at these things, where it's just like, what is the exposure potential here? I think with something like React, again, it's kind of like, well, I don't know, give the major versions a little bit of time to cook. They're just it's so big. It's probably better to be a little bit more forward. But then on something that maybe it doesn't have as huge a user base, it's like maybe be a little more cautious. But it is tough because it feels case by case. And yeah, like there are tools kind of coming into being that some of them are like part of the tooling itself, and they're like in the open source world. There's like paid options that are trying to kind of come up with a way to do this. Is there anything that gives you particular like hope, I guess, for the JavaScript ecosystem where we won't be in this mode? Because we had a few years that felt quieter, and now it kind of feels like there's stuff is all moving again. Do you think that there's a light at the end of this tunnel? Is this the new reality? Where are we right now?
I think there's a bit of both. I think JavaScript has now come into itself as the most popular language, and that's driven by AI. But we can't just blame AI for everything. So that's the driving factor. And you saw it in the old days when there were never any exploits or attacks on Mac OS or the Apple ecosystem. Right. It was all Windows. And there's two reasons. One, Windows was the most popular. And then two, Windows had some very insecure defaults. It took them a while to fix that.
Right.
And now that's changed quite a bit. And you see a lot of the really interesting zero-day exploits are for iOS, because most people who you might want to attack are on iOS, even though Android still does also have a lot of exploits. And I think it's the same with JavaScript, is you can pretty much guarantee a front end is built in JavaScript. So the question becomes, well, what's the back end built in? And increasingly it is JavaScript. It is the language that is being used. Even though it wasn't designed for that, and it's arguably not the best for that in certain circumstances. It depends what you're building.
Yeah.
And that's just the reality that we have to accept. But the challenge here is that the default for the packaging ecosystem is NPM. Microsoft and GitHub acquired NPM a long time ago and have seemingly just let it sit for a long time. And it's only in the last few months that they've been kickstarted into making a lot of really important improvements to the package publishing process and to how security is handled with NPM, because of these vulnerabilities. Yeah. And really, that's just a commentary on humanity, is like we do nothing, even though we see the problems, until something really bad happens.
Yeah, until something's on fire.
Yeah. And then we figure out how to solve it. And often we come to a really good solution, and we're then in a much better situation.
You've used the term secure by default a few times. There's tooling on the supply chain, on like the build side, and there's stuff on the more on the server side as well, but I feel like those are going to be a little bit more case by case. Is this just a function of like the stuff that we're doing needs to be like more mature and it'll get better over time? The RSC paradigm is kind of new. I guess it's kind of, it's built on old things like everything is, but like it's a kind of a new way. Like, GraphQL was new over our REST APIs of old. Like, is this one of those things where like, is this growing pains as we shift to a new paradigm, or is this like something just inherent to JavaScript that's going to take some time to get through? Like, what's your outlook there?
Yeah, well, the RSC implementation is very new and it has a lot of constraints. Just because it's so new, there are going to be vulnerabilities. There are going to be things that need to be redesigned or rethought. You can just look through how Next server actions has evolved a few times. They were previously just exposed API endpoints. Now there's some obfuscation in there. They do a lot more work on hiding them. making them so that you can't just exploit them or discover them. And so security evolves over time, and your risk appetite really depends on that question of, well, do you want to adopt this brand new thing, knowing that it brings certain benefits, but also knowing that it's highly likely there are going to be significant problems.
Mm-hmm.
Like the other way to do it is just you don't use JavaScript on the server side at all, and you use a more mature language.
Mm-hmm.
And that might be the right thing for certain areas of your application, but there is a huge advantage of having everything in the same code base and being built in the same way and then deployed in the same way. Yeah. But it's just going to be a trade-off, and it's being exacerbated by the state of the JavaScript community. It's not inherently because of the features of the community that we've discussed, but it's being exacerbated by the fact that it's all brand new.
It feels to me like there's a lot of magic which goes on now. You pull a framework off the shelf, it's like, okay, we're just going to do all this stuff for you. Is that magic leading to some of these problems, or is it just kind of a problem because it is more powerful and there's going to be some problems in there?
I feel like frameworks like Next.js have reached peak complexity and potentially just the peak. And we're seeing like people move, like you have
hopefully
to,
I guess, I don't know.
Yeah, I know. It's just there are so many components to it. Like components, no pun intended. There's so many different things you have to understand. And then you have the magic directives like use server, use client,
right.
Proprietary ones like use workflow. It just becomes very, very complex. And I wonder whether we've hit the peak here because the buzz on social media is moving to other frameworks that are much simpler.
Yeah.
Remix is trying to do this by adopting the native web APIs, which have improved significantly to the point where you can actually use them in your application. Mm-hmm. And Remix tried that, and arguably they were very successful in certain ways, but it didn't hit the level of success as Next.js has. And it's not that Next.js is going away because it's so popular, it's adopted by so many organizations. It is I don't want to call it the Java of the web, but it's kind of like that in the level of adoption it has. Right. But there are new frameworks all the time in JavaScript, which is a problem. But some of them are picking up really interesting ideas. Like TanStack, for instance, that framework wasn't vulnerable because it doesn't use React server components. They just haven't implemented them yet.
Yeah.
And maybe that was luck, but also maybe it was a decision that they made because they thought, well, this is too complicated. How are we going to do this? How are we going to make the developer experience such that people can understand it? And I think this happens when you have so much complexity just out of the box by default. That your mental model for how the framework is working, where the communication is happening, and what's executing where is very difficult to understand. And often the defaults are changing all the time.
You see it everywhere across technology. There's like these cycles of like new tech is simple, like the abstractions are clean, it looks good, it feels good to develop in. You start working on it for a while, the community grows, there's all these requests for features and you want the new thing, and just like the fundamental tech driving stuff changes over time. So you take this paradigm that you established 15 years ago and you're trying to like update it and stuff, and then it becomes more, and then there's another new one that's like, hey, we're a clean slate, come do this thing. Maybe that's kind of to my prior question of like, why does this feel worse now? Maybe it's because we're at this complexity peak, and I wonder if historically those are like at least kind of conceptually been like occurring at the same time, where the ecosystem gets huge and complicated and the surface area is larger, so like there's more vulnerabilities and there's something new and clean and easier to reason over the abstractions. And even though it's less mature, it's just like it's not as complicated.
I think there's an interesting analogy to C and C++ with memory safety.
Oh, yeah, nice.
Like web developers don't have to think about memory safety. It's not a thing. It's not part of JavaScript. And languages like Python and Go, they're just not vulnerable to that class of challenge because you don't manage memory manually. And this is very different in C. You really have to know what you're doing and you have to do it deliberately. And even when you have everything there, in the perfect case, you could still make a mistake or do something in a strange way that causes a memory vulnerability.
Right.
And a lot of the vulnerabilities in operating systems and classic systems are due to that lack of inherent memory safety. And so the way that modern languages resolve that is by making sure that developers can't make that mistake by doing it for them.
Yeah.
And we reached the peak of those kind of vulnerabilities because of the popularity of C and those style languages. And they've started to trail off as critical systems have been replaced by memory safe language, or frameworks have been put in place to kind of detect them
Yeah.
And you've just the class hasn't been eliminated because there's still going to be those kind of vulnerabilities, but it's on the downtrend. And I just wonder whether that's the same in JavaScript. They're not the same kind of vulnerabilities, but it's maybe the same concept because it's hit popularity. There are still areas that are mature and immature, and we just haven't really started to think through how to mitigate these at a fundamental level.
Do you think Reactor Shell is going to kind of be a wake-up call in the same way that I do feel that the Shai-Hulud stuff was for devs and their dependencies? Do you think there'll be much of one on the Reactor Shell side, or is this just going to be kind of one of those, that was a bad bug, it's fixed now, there's not a huge process change here?
I think we're ending the year with JavaScript developers much more aware of security. You've had the attacks on their own systems and their laptops, and now we've had attacks on production applications. And with the Shai-Hulud, you can actually take steps to mitigate it directly by improving how you run your supply chain.
Yeah.
With Reactor Shell, there's not really anything you could have done
to do. Yeah, exactly.
It's more just thinking through who's providing the platform. Did they do proactive mitigations, or did they require me to do something? So like Vercel and Netlify, for example, they did proactive mitigations, whereas the classic cloud platforms like AWS and Google just gave you rules which you could enable. Yeah. And then Cloudflare was a slightly different scenario because they patched and then caused an outage as a result of that. It's easy to laugh at that, but they are running at such large scale that they see so many.
I wasn't laughing at their thing. I'm just like, it's a very Cloudflare thing to have happen. Like, that's absolutely like, if you're to ask me which provider responded in this way, it's like, that's probably Cloudflare.
Yeah. And they've had a few issues recently, which has exacerbated the pain that people felt as a result of that. But different platforms take things in different directions. And so it's understanding how that works at the same time as knowing how you manage your upgrades when you need to and how that happens quickly if necessary.
Those are probably as good of recommendations as any. Is there anything else you'd kind of advise devs that are just kind of feeling a little bit frustrated and like what to what to look at, what to be thinking about a little bit more proactively potentially?
Those are the main things. They're thinking about your development environment and then how your production environment interact. But I think developers get a bad reputation for not caring about security, but they actually think about security in a very different way because the incentives are so different. Developers are there to build features and solve customer problems, whereas security is about minimizing risk, and they have to work together. But because the incentives are misaligned, there's often tension there. Yeah. And the way that we tried to get developers to think about it with our own product is around thinking about security as a feature and how you can embed security into how your application actually behaves, into your logic. And that's a different way. Secure by design is kind of the marketing line for it, but it's really thinking about how your application behaves in different scenarios, what tools you have in there, how you can test it on your laptop, and works the same as in production, because often these are separate systems. The WAF is only ever deployed in production, so how do you know how it's changing your application? You can't actually test it, and it's a very different. It's a different problem that it's solving, and this is what we're trying to do with Arcjet, is to bring those a lot closer, because they are different disciplines, but they also have to work together. And I think this is the future of security, is thinking about it much more in your code rather than as someone else is dealing with it. It's a separate system. We have to bring it into the logic of how your application runs.
There is a little bit of a spectrum of the like dependency vulnerabilities versus application logic vulnerabilities. Like those do feel different, and there probably is like different kinds of tools and like a long-term approach to have that and think about those things. I think having things that one is able to pull off the shelf to help facilitate, and again, I think we're seeing those products come into their own a little bit more, will be helpful. Is there anything else you'd like to kind of point listeners towards or advocate for?
The development environment is where I think there's a lot of low-hanging fruit. Like I mentioned, we use dev containers. Things like putting your secrets into a password manager and having Git make a request to it rather than having your keys on disk. They're very simple things. Like the attacker mindset is very different from the developer mindset, because the attacker is how do I break versus the developer is how do I build. And when you start putting your mindset into the security mode, you think, well, how could I abuse this application or get access to this. And it's things like, oh, you got credentials on your disks. I can read they're in plain text, or I can send requests out of the environment to somewhere because I don't have an outbound firewall.
Right.
There are all these little things that you can think about how someone might compromise your environment that can improve your own posture.
Yeah. Cool. Well, yeah, I think that's all I'm going to grill you on right now, David. Thank you for coming on and chatting with me today about JavaScript and vulnerabilities.
Yeah, it was fun. Thanks a lot.
Of course. Have a good one.